All right, so a couple things off the top. All right. All right, so a couple things off the top. Making this transition, maybe I haven't been clear. I've said this a couple times, so if you're getting tired of hearing it, what do you have to do after class? Yeah, these questions we go through at the end of class, I'm incentivizing you to come to class so you can get the answers and then get on and get them done on these assignments on top of that. So I think maybe part of it, calling them class participation, because that's what we were originally using to kind of replace the in-class participation points. I'll start calling these now, and you can't see this assignment yet. Oh, there you go. But I'll start calling them instead. Maybe this will help. Just going to call them class questions, right? So it doesn't matter if you're in class or not. You still can take a stab at them. Although if you're in class, you're definitely going to know the right answers, right? So you should be able to easily get those 4 out of 4 points. If you don't show up this week, for example, or today, for example, there's only 2 questions, each worth 2 points. You weren't in class, you're not sure you answered it wrong, you're only getting half or 50% on that, right? So still incentivizing you to kind of show up, make sure you're going to see me work through these in class. These should be relatively kind of, should be able to get the correct answer. So we'll keep using this method throughout the semester. I'm not really planning on the Wi-Fi being able to kind of work in this room. So that's what we're going to do kind of moving forward, okay? Any questions on that? So the other issue, and I put an announcement up on Canvas about this, there are probably 15 to 20 of you, some of you have started to change it, you've seen the announcement. If your packback is showing up as a 0 on Canvas, it's because when I first walked you through, and I understand that not blaming you, or this is easy to do, but I said to first access packback the first time through this link on the Canvas page on the left-hand side. By clicking this link from Canvas and it sends you to the packback, it links up your accounts. If you haven't done that, I can see that your account isn't linked and I'm not able to automatically sync up your grade, right? So if you haven't done that yet, make sure if you're seeing a 0 on packback and you know you did the assignment, you go to the Canvas page and click this link on packback, okay? Once you get that account synced up, now I can sync the grades over and yours will kind of upload, okay? Any questions on that? Yeah. Nope. Any other questions on that before we keep going? Just kind of housekeeping stuff. All right, so what you will have this week is I'll pop up after class that week 4 module quiz. So you've got the practice problems, CL sessions this Thursday and Sunday. You won't have a module reading because what's a week from today? Yeah, in-class exam, right? So we'll talk a lot more about that on Tuesday. We'll do a lot of exam review on Tuesday. I'll kind of just mention today, if you want to start studying for the exam, you've got that practice exam and those practice exam answers. I would kind of start there, right? So that's going to be the best representative, that's going to represent the best what the exam will look like, right? So working through those problems, you're not sure why the correct answer is what it is, might be a good thing to stop by my office hours, either Monday or Wednesday of next week. Also in class, make sure you're bringing those questions that you have. I'll field the class for questions so I know that I'm working through problems that people have issues with, right? As opposed to me just kind of working all the way through, because we wouldn't have time probably in one class to work through every single problem, right? After you look at those practice problems, as cliche as it is, the best way to learn is from understanding why you made mistakes, right? So go back to those old quizzes, especially the ones you got wrong. Make sure you know why the correct answer is what it is, right? After you do that, I would then kind of take a look at the practice problems. If you want more kind of study material, you want just more practicing of these problems, I think doing more problems, just seeing more variants is going to be beneficial. So that's kind of the order in which I would start studying for this exam. And like I said, you can read your notes all you want. I think working through the problems is what's going to be the most beneficial. Yeah. Somewhat similar, right? I might make some of those a little harder because you've got your notes and everything available to you, right? So like I said, the degree to the difficulty and kind of the style, the types of questions, that practice exam is going to be your best imitation of the exam. They can be. Some of them, any one question might be a little bit, but about the same difficulty. Some of them might be a little bit harder because you do have your notes and everything available to you. Yep. All right. So once again, we'll talk a lot more about the exam on Tuesday. Review for it. Other than that, there's no other questions. We'll kind of jump into this module 4 material. Yeah. No. No, she was asking about the quiz questions. I said those are more difficult because you have everything available to you when you sit down to take the quiz, right? I'm not there making sure you're not looking at your notes. On the exam, you will be given the exam. If you want some extra paper, blank paper to write on, other than that, though, no. Yep. Yeah. Yeah, sorry. Calculator as well. Yeah. Because I don't see how I can do an exam like this. Well, what do you think? I mean, it's in, so how have I referenced this exam? It's an in-class exam. All right, guys, hold on. So we'll be taking the exam. We'll meet at the same exact time we have class because there's 300 people. Your schedules would all overlap. You all have this time period available. So I get that it may not be ideal. I don't know, email the university, tell them that you want bigger lecture hall, the lecture hall to have bigger desks, but we'll have to make do with what we have, right? So we'll be taking the exam in class, right, on Thursday, okay? Any other questions before we dive into material? Okay. Sorry if you're not happy about that, but that logistically is the only way that we can do it is to do these exams in class, all right? So, whoops, get out of here. Where did we leave off last class? Is there something going on? Yeah. Why is everyone talking? All right, guys, we'll talk more about the exam on Tuesday. It's going to be the entire length of the class, right? We are meeting just like we would for class, but that class period will be the exam, right? So we will meet here at 3. You will take the exam until 4:15. You want all the time, right? We'll be in this room, okay? Is that clear? I'm good with that? Okay. So we got to get through some material here today. Answer all of your questions if you still have some on the exam about the exam on Tuesday, okay? So we left off talking about elasticity and its relationship to kind of slope. We said they're not the same. In fact, we were talking about elasticity of like the entire demand curve in a way, and we were just kind of setting some up for what we're going to do today, because we actually look at a linear demand curve, the slope will be the same at every single point, right? We've got these nice linear demand curves. However, your elasticity is going to be different. In fact, as we move down that demand curve, our demand becomes more and more inelastic. So why is that going on, right? And I think my black marker died on me today, so we're going to be doing green, I guess. So if we have our demand curve, right? Initially, I'm just going to give some numbers to make this kind of easier to think about. When I'm at relatively high prices, I might be moving from something like 99 to 100, right? As I lower the price, I know what's going to be happening to the quantity demanded. It should be going up, right? The lower the price, people are going to want to buy more. If we think about what our elasticity of demand was, it was our price elasticity of demand. So what was changing? Our price, so that was in our denominator. What was responding to that price change? Our quantity demanded, okay? So anytime I'm up on these higher points or higher portions of the demand curve, what's going to be true about this percentage change in quantity? Going from 1 to 2 is a very big or large percentage change, right? I'm doubling it, right? So I'm going to have a very large percent change in my quantity demanded. What's going to be true about the percent change in price? Well, if it's starting out at 100 and it only goes down by 1, that's going to be a very small percentage change. If you want to, you could use the midpoint method and calculate what this actual percent change is, but it's going to be relatively small. So what's going to be true about my demand? Is it going to be elastic or inelastic? Yeah, a very large number over a smaller number, it's going to be greater than 1, which is what we said was elastic, right? So here, up at the top part, we're going to be on the inelastic. We're going to be on the elastic portion of our demand curve, okay? as we move down the demand curve, and just using extreme numbers to kind of make the point initially, eventually I'll get down to here, where now I'm thinking about the price maybe is falling from $2 to $1. And now maybe the quantity demanded is going from 99 to 100. So now what's going to be true about my percent changes? So that percent change in the price is going to be relatively what? So if I have a pretty small number, it's a pretty large percent, right? It's going down by 1. It was getting cut in like half, right? So whenever I have small numbers, that same 1 unit change right before, that 1 unit change was a very small percent. Now it's a very large percentage change. Once again, you could plug this into your midpoint method and kind of convince yourself of this. So you can plug them into that midpoint, do the change over the average. We're thinking about percent changes, right? If I go from 1 to 2, that's like doubling, right? It's a large percent change. If I'm going from 100 to 101, still a 1 unit increase, but it's a really small percent change, right? 1 out of 100 is very small. So that I'm just, kind of thinking about the size change of those numbers. So if I'm going from 100 to 99, 99 to 100, what's that going to be? A relatively small percentage change, which means my elasticity is going to be less than 1. Or once I get to the lower parts of my demand curve, I'm going to be on what we call the inelastic portion. So what ends up being true, and I use the extremes, as I'm moving down my demand curve, demand is becoming more and more inelastic. So, the elasticity up here might be 10, then 5, then 2.5, kind of all the way down until we get down here where it starts to get really close to 0. Okay? Now, there will also be a point on this demand curve, and I'll draw it a little bigger than it actually is because it's really going to be just like in between 2 specific prices, where we are at that unit elastic point where our percent change in quantity is the exact same as our percent change in price. So we're starting out very elastic, becoming less and less elastic, hit the unit elastic point. If we continue to kind of move down the demand curve by lowering this price, we end up on an inelastic portion of the demand curve. Okay? Any questions on that? Okay? So slope is always the same, elasticity is not. It's the end result there. So I'll give you guys a little bit of time. If you're still writing this, we've got the nice projectors on the side here so we can kind of keep going. So I've got here, let's say I had this demand curve, and you could use that midpoint method to come up with the values that I'm about to kind of show you. Okay. So let's get all these up here since I know this one's larger and a little bit easier for everyone to not crane their neck. So initially, I might see the same $10 decrease in price, right? I'm going from 30 to 20. My quantity from that change is moving from 0 to 20, right? If I use that midpoint method and calculate the elasticity here, it's going to end up being 5, right? So I would just take my 2 quantities, take my 2 prices, plug them into that midpoint method where we took the change in quantity divided by the average quantity, divided by the change in price, divided by the average price, right? That's what we did last class. So they were not focusing on much as calculating these percentage changes or calculating the elasticity, but understanding what's happening to the elasticity as we move to different points on the demand curve. If I have that same $10 decrease, right, this portion of the demand curve, where the price goes from 20 to 10, quantity goes from 20 to 40, if I calculate my percentage changes here, they end up being exactly the same. So now we would call this the unit elastic portion of our demand curve, right? It was exactly equal to 1, right? And then as we continue to go down, now that same $10 decrease in price going from 10 to 0, quantity goes from 40 to 60, we'd end up having a relatively small elasticity measure, less than 1. Now we're on the inelastic portion. Okay? So this will always be true. Right? Your unit elastic point is kind of in the middle. Top part of your demand is elastic. You get to the bottom, you're on the inelastic portion. Okay? Any questions on this before we keep moving? So it's kind of a different view of what I drew here. The numbers aren't quite as extreme, so it's harder to think about the percentage changes. I think using 1 and 2 and 199, it's a little bit more clear. So why do we care about this price elasticity of demand? Well, we might care about it a little bit, but companies really care about it, right? Because think about it this way. If I had perfectly inelastic demand, we said that was I can change the price and people keep buying the exact same amount. The percent change in quantity demand would be 0, right? Well, what implication does that have for a company? If I can increase the price and people keep buying the same amount, what's happening to my revenues? Going up, right? Selling the same number, but at a higher price. So we think about total revenues. The way we're going to calculate or think about this is it's simply the number of units I'm selling times however much I'm selling them for. So price times quantity. Well, those are two things that, right? That's our relationship that we're graphing out with our demand curve, price and quantity. So we can think about it this way. I'll do it one way now, come back to the slides, slightly different way. Some ways might connect with some people, the other way might connect with others. So I like to do both. So we're thinking about total revenue is going to be price times quantity, okay? If I have elastic demand, we know that percentage change in the quantity demanded divided by the percentage change in price is greater than 1. So what has to be true about the relationship between the percent change in quantity demanded and the percentage change in price? What's the only way this fraction is greater than 1? Yeah, that percent change in quantity demanded has to be a higher value, right? And that's what we said. Demand is elastic. People are more responsive than the price change that's occurring in terms of percentages. So if I were to, let's say, increase the price here, well, didn't save myself enough room. I really wanted to kind of make this point. So if I increase the price here, right, it's going to be a relatively smaller percentage change. I know that the percent change in quantity demanded has to be larger. So if I increase the price, people are going to buy a lot less, right? So the kind of size of these arrows I'm using to kind of represent the fact that we know that percent change in quantity demanded will be larger. Right? So what's going to happen to my total revenues? Well, I made a little bit more money off of every unit I was selling, but what happened to the number of units I'm now selling? It went way, way down, right? So overall there, if I'm on the elastic portion of our demand curve, increasing the price is actually going to decrease my total revenues, okay? Well, what if I had, use colors here, what if I was on the inelastic portion and I wanted to think about that same price decrease, how would it impact my total revenues? Well, if we're on the inelastic portion, we know that our elasticity is going to be what? Less than 1, which would imply that the percentage change in our quantity demanded is what relative to the percentage change in price? Yeah, it has to be less than. That's the only way this fraction is less than 1. So now when I'm thinking about my total revenues, if I were to decrease the price, that's going to be on the inelastic portion, relatively large percent changes in the price are going to result in a very small, oh, I did this wrong way, sorry. We had increases in price here is what I started out with. So let's say I increase the price by quite a bit. If I'm on the inelastic portion, we know that the response from consumers, the amount that they're going to buy, it's going to go down, but not by as much, right? So what's the overall effect on total revenues? Well, that percent change in price was going to outweigh the percent change in quantity demanded. So here, increases in price actually increase total revenues. So this is one way of thinking about it. I've got a slightly different way in the slides, and then I'll have a way to kind of maybe tie this all together, okay? So elastic portion, price increases will decrease total revenue. Inelastic portion, price increases are going to increase our total revenues. Here's another kind of look as to how this is working, right? And so if the arrows don't make as much sense to you, maybe this will, right? So we have these kind of different price and quantity combinations. I can find total revenue pretty easy. It's just price times quantity, right? So here, if I'm charging a price of 5, nobody's buying my good, I'm making $0. If I then lower the price to 4, one person who's going to buy this good, I'm now making a total revenue of $4. Lower the price to 3, 2 people are going to buy the good, now I'm at a total revenue of 6. If I go through and calculate the elasticity between each one of these price changes, initially, I'm going to have relatively large elasticity values, right? My demand is going to start out elastic, right, on that upper portion of the demand curve. So notice when demand is elastic, by decreasing the price, I am actually increasing my total revenues. Once again, demand is still elastic, not quite as elastic. So now that same change in the price, it's still going to increase my total revenues by not as much, right? Before we went from 0 to 4, now we're only going from 4 to 6, right? And then what if I'm on the unit elastic point? Well, there changes in the price offset each other. I actually have no change in my total revenue. If I keep on lowering the price, once I get to that inelastic portion, now as I keep lowering the price, right? Yeah, I mean, I'm convincing more people to buy this good, but they're not as responsive. So I'm losing money by selling this good at a lower price and not making up for that because I'm not selling that many more units. So when we're on this inelastic portion, notice a price decrease starts to decrease my total revenues. Okay? So I'll draw out this relationship that I think will help make a little more sense than these values. But there is one additional way I want to think about this, and then I'll come back to those other slides. I'm going a little bit out of order, but I think given what I've said, this will make sense. So let's say I have that demand curve. It's the exact numbers we were just looking at from that table. Okay? If I decrease the price, or if I start out selling this good at a price of $4, I'm only going to be able to sell one unit, right? Go over to where I'm at in my demand curve. At $4, I'm selling one unit. So my total revenue is going to be $4. If I lower the price to 3, right? Well, now I am selling 2 units, but by lowering the price, I lost $1 on that unit I was already selling, but I'm now selling an additional unit and making $3. So am I better off? Yeah, right? I lost $1, gained 3. My total revenue would go up by 2. Right? When we're on the unit elastic point, notice there if I'm decreasing the price from 3 to 2, those previous 2 units I was selling, I'm now losing $1 on each of those, but I'm selling this third unit. How much am I making off that third unit? Well, I've lowered the price to $2, so I'm gaining an additional $2. At the unit elastic point, this would completely offset each other. If I then continue, I know that if I go past the unit elastic point, I'll be on my inelastic portion of the demand curve, right? So here, if I continue to lower the price, I'm going to lose $1 on each of those previous 3 units I was selling if I lower the price from 2 to 1. And yes, I've sold now a 4th unit, but I'm only selling it for $1, so I've only gained 1. So here, if I'd lowered the price, am I better off? No, right? I actually decreased my total revenues. Okay. Excuse me. So just kind of a different way of seeing kind of this trade-off, right? Between when we're lowering our price, yes, we'll sell more units, but that kind of relative size of that price and quantity demand change, we can get that from the elasticity, right? Which is larger, the percent change in price or the percent change in quantity demanded? We can say which one is larger if we know if we're on the inelastic or elastic portion of our demand curve, okay? So that's the graph I want to draw. I skipped over some stuff though, so we'll kind of come back here. This is just kind of a general rule. This is trade-off decision that as I'm lowering the price, I'm selling more units, right? So I'm making a little bit less on each unit I was selling, but I'm selling more units. Reverse. If I increase the price, yes, I'm selling fewer units, but I'm making more money on each unit that I'm still selling. Okay? So kind of what we want to get to, and I kind of have it here, our total revenues are going to be maximized at that unit elastic point. We saw that from this table, right? At the unit elastic point, that was the highest possible total revenue we could get. So another way of visualizing this, and this is, I think, instead of like trying to memorize, like exactly, okay, when I'm on the elastic portion, if I increase the price, I have to think about the relative size. So which one is going to be larger? You really don't have to go through all that if you use what I'm about to draw, right? So I think it makes it easier if we always know that this relationship between our demand curve, right? So we'll say here, this is going to be kind of our unit elastic point on our demand curve. So we know up here, we're on the elastic portion, and we know that down here, we're on our inelastic portion. So I'm going to map out right underneath it Still looking at quantities, right? So the quantity of the good I'm selling, but instead of price here, I'm going to put, in kind of terms of dollars, my total revenue, right? So if I were to use the numbers from the slides and graph this out, this is kind of what it would look like, although I'm going to draw it even more continuous. It wouldn't just have to be 5 different prices. So starting out, if I am charging this price, what's my total revenue? I'm selling 0 units, so my total revenue is 0, right? So as I kind of start to decrease this price on the elastic portion of our demand curve, and we said before, right, we could kind of draw it with the arrows, but this means if it's elastic, that percent change in quantity demanded is larger than the percent change in price. So even though we're lowering the price, that's going to be a really small percentage change. And the amount of units purchased, that percent change is going to be very large. So it's going to more than compensate for that price reduction. And as we decrease the price, we start to see our total revenues are increasing. Okay. So once again, you could draw just out the 5 points. I'm just making it more continuous here. So at this unit elastic point, this is going to be where you can kind of think about total revenues should be maximized. If I get to this point and I continue to lower the price, well, now my demand is inelastic. So by lowering the price, yes, I'm convincing people to buy a little bit more, but keyword there, just a little. So I'm losing a bunch of money by lowering the price, and I'm not selling that many more units. So if I continue to lower the price on the inelastic portion, now my total revenues are decreasing. Right? So if I'm looking at this, no matter where I'm at on my demand curve, what do I want to do? Move towards the unit elastic quantity, right? And so that's a little bit easier than kind of memorizing exactly what the relation. If I have this drawn out and you tell me I'm on the inelastic portion of the demand curve, I know I'm somewhere over here. I know that in order to increase total revenues, I should be moving back to that unit elastic point. How do I do that? I'm raising the price, right? If I'm on the elastic portion, how do I move towards that unit elastic point, or how do I increase revenues? Well, there I should be decreasing the price. Right? So anytime we're on the elastic portion, we want to move towards the unit elastic point. In order to increase revenues, we need to decrease the price. If we're ever on the inelastic portion, we need to move towards that unit elastic point. How do we do that? We need to start increasing the price. Okay. So this, I think, is for most people, like I think this prevents you from making kind of mistakes when working through questions related to elasticity and total revenue. Okay. Any questions on this before we keep moving? Okay. All right. So I think I've got an example here. So we already kind of went through this. This is, once again, I leave these blank slides. That's what we just drew, right? So it's honestly a way to remind me that there's a really important drawing that I need to make sure I draw out for you, right? So I've got these. You don't have to worry about those. I do want to pull open this because I think it's kind of interesting. We can see it in practice, and it revisits that midpoint method. So I put this Excel file up on Canvas. I think I called it movie theater or movie tickets or something. It's basically got kind of I grabbed this data. It was yearly data, the total box office kind of sales of major movie theater chains. Now, obviously, like COVID happened here, so we probably can't really use this data. It's going to be a little bit skewed. So this isn't perfect because really, in order to understand this relationship between price and total revenues, I should be holding everything else constant. In practice, year to year, what changes? Changes in income, price of substitute goods change, right? All these other factors that we talked about last class are going to change, right? So it's not perfect, but it ends up working out for us that most of those factors remain pretty constant for movie theater tickets. It's not like there was like all of a sudden some brand new substitute or, you know, relative price of substitutes were staying the same. So we're actually going to look at from year to year what happened when the price of movie theater tickets was increasing. So I'm not going to expect you guys to ever do work in Excel. I'm just going to use it to kind of highlight this fact, right? So notice when I'm finding these percentage changes, if you're using the midpoint method, we describe these as percentage changes, but the actual numbers you see are going to be in decimal form, right? So here, when I calculate the percent change in quantity, It looks like it's negative 0.016. That's a 1.6% change, right? Now, for you, it doesn't matter. I don't ask you to calculate just the percentage change. I ask you to calculate the elasticity. So in which case, when you take that percent change in quantity divided by the percent change in price, it doesn't matter that you're dealing with a decimal form, right? It can all cancels out. So what we're first going to do is say, okay, look, moving from 2018 to 2019, what was the change in the quantity, the number of tickets sold, right? So I'm just going to take what my new quantity is minus my old quantity. Now in Excel, I use cell references here. For you, you'd actually type the number into your calculator, right? Or write it into the formula. We would then divide by the average of those quantities, right? So that's all I'm doing here is kind of that numerator for our midpoint method. Right? I then said, okay, what else do I need to find the elasticity? I need the percentage change. So I'm going to take that ticket price, take my new minus my old, find that change in the price, divide it by the average. How do we find the average of two numbers? Add them up, divide by 2. Okay. Once I have those, I've got my numerator and my denominator. I'm just going to take that numerator, divide it by my denominator. Okay. So I end up seeing here what's true about the elasticity for movie theater tickets. At least between these two time periods, it was pretty elastic, right? So if it was elastic and we saw increases in the price, which is what kind of point that companies don't always do the smart things. If I'm on the elastic portion and I increase the price, what's happening to my total revenues? Going down, right? If I'm moving to higher prices, my total revenues are going to decline. Sure enough, if I looked at kind of that growth, the box office, the total revenue column here, total box office sales, what happened in between these 2 years? It actually went down a little bit, right? So increases in price when you're on the elastic portion are going to decrease our total revenues. Here we've got some like kind of real world data that actually proves this to us, right? Now, once again, it's not perfect because there's other things changing like in the world, but pretty good evidence that kind of lines up with exactly what we're talking about in class. And I think the original file didn't have it. You could do it at different years, and you'll always kind of see that movie theater tickets are pretty elastic. And you know, when we're increasing the price, we're seeing that their revenues are declining. So why do they keep increasing the price? I'm not entirely sure, right? Because they're moving away from that point where they're getting maximizing total revenue. Now, we haven't factored in costs and things like that yet. So we're just talking about if we were trying to maximize total revenues, what we should be doing, okay? Any questions on this before we keep moving here? We're good? All right. So let's go back here. Now that we've kind of talked about price elasticity of demand, we're going to talk about a few other elasticities as well, right? So the first one we're going to talk about is this cross price elasticity, right? So we know that goods can be related. We talked about there's substitutes in consumption and there's complements in consumption, right? So if I think about my cross price elasticity, this looks very similar to what we're doing with price elasticity of demand. It's just now I'm looking at a change not in the price of good X, but the change in the price of some other good, okay? So here I've got kind of the percentage change in the price of some other good. So with the price elasticity of demand, what were we always kind of ignoring? Or the very last step was we had to take the absolute value, right? We were ignoring the negative sign because it was always negative. We know the relationship between price and quantity demanded for the same, you know, when we're looking at one good. Here, when we're dealing with other elasticities, we do not want to ignore the negative sign. The sign will actually tell us something about the two goods. So think about why. Let's say we had substitutes. If I see an increase in the price of good Y, and as a result, people buy more of good X, that's telling me these two good are substitutes, right? So this is the idea. If the price of Pepsi goes up, we'll see the demand for Coke increase. Substitute goods, that price and quantity demanded, move in the same direction. So anytime we have them moving in the same direction, our cross price elasticity will be positive. We'll either have a positive over a positive or a negative over a negative. Right? So anytime you have a positive cross price elasticity, that's evidence that those two goods are going to be substitutes in consumption. Okay. Any questions on that? So we're using things we've already talked about from earlier modules, just kind of applying it to elasticities now. what if the price goes up and I see that the demand, the price of good Y goes up and I see the demand for X goes down, what would that be telling me about the two goods? They're complements, right? So anytime the price, so that's like the idea of anything that requires batteries, right? If the price of batteries goes up, my demand for, slide clickers, or if we think about for vehicles, if electric batteries for electric vehicles, the price goes way up, the demand for electric vehicles is going to go way down, right? They're moving in opposite directions. So there I would have either a positive over a negative or a negative over a positive. So I'm going to have a negative cross price elasticity, which would indicate these are complements in consumption. So I don't ignore the sign when I calculate this cross price elasticity because it tells me something about the relationship of the two goods. Okay. Any questions? This. I forgot some I'll show you in just a second too, but I wanted to introduce the next one. I'll also mention at this point, I'm not going to make you do it, but like you can actually tell how much of a substitute something is by this, like, so we don't use the ranges of like, is this a cross price elasticity inelastic or elastic? But what that would tell you that if that cross price elasticity got higher and higher, that's telling you that they are stronger substitutes or stronger complements. Right? But I won't push you guys quite that far. I just want you to know that the sign of this cross price elasticity will allow you to identify what the relationship is between those two goods. Okay. So the next one is going to be income elasticity. So for a normal good, we said when we have more money, we demand, for a normal good, you have more income, you'll demand more of it. So they're moving in the same direction. So positive over a positive or negative over negative. Our positive income elasticity will tell us if this good is a normal good. If we have an inferior good, then increases in our income are going to do what? The demand for that product. Inferior goods, you have more money, you will buy less of them. So there, positive or negative over positive or positive over negative, there we have a negative income elasticity. That's telling us it's an inferior good. Okay. So the sign, once again, we don't ignore it with income elasticities. And this is the income elasticity of demand. And here I really should, to be complete, as we are looking at demand, the cross price elasticity of demand. All right. So these are kind of the two additional elasticities we're now talking about. Now, you might start to think, okay, these equations are hard to remember. What's in the numerator? What's in the denominator? I kind of have what I think is a very helpful way to remember this. Okay. So when we're talking about the price elasticity of demand, how are we calculating this elasticity? Well, whatever this first word is, whatever comes before that word elasticity, that's the thing that's changing. That's what goes into your denominator. And then it's the price elasticity of what? So here's what's the original change was in the price. What is being elastic or what is responding to that price change? Here we had demand, so percentage change in our quantity demanded. So that first word is always what's in your denominator. Second word is what's going to be in your numerator. We'll kind of go through. What if I had cross price elasticity, and I'll just kind of abbreviate that, of demand? Well, when we're looking at the cross price elasticity, that thing that comes first, that's going to be in my denominator. So cross price, it's a percentage change in the price of some other good, right? Or a percentage change in the price of this other good Y. What are we wanting to know? How, what is responding to that change in price? It's going to be a percentage change in the quantity demanded of the good X that we were looking at. If it helps here we were looking at a price and quantity change of the same good. Right? Now we're looking at a cross price elasticity of demand. It'll be how does the quantity demand respond for good X when I have a change in the price of something else, the cross price. Okay. And then if I have income elasticity of demand, so here I had this, what's going to go in my denominator? The first word, so I'm going to have a percent change in income. What goes into my numerator? Well, here was the percentage change in quantity demanded. Okay. Now, yeah. Oh, sorry. There you go. So luckily for us, right, all three of these, another way to remember kind of what goes in the numerator, what's in the numerator of all of these? The percent change in the quantity demanded of good X, right? Or whatever good we're looking at. So you should always have that percent change in quantity in your numerator, okay? Any other questions on this before I go back to the slides? Okay, so we won't do it in this class, but you could actually come up with elasticities of anything. You could think about measuring the elasticity of, the force that I'm using on pushing this screen away from me or something like that. So it doesn't have to always be quantity in our numerator. It's just for the sake of what we're doing in the economics context, we're always having that change in quantity demanded in that numerator. Okay? With one exception, although it shouldn't confuse us, is we can also talk about, well, I skipped ahead. I'll hold off on that statement. So we've just talked about demand so far. So I won't really push, like, you'll look at the practice questions and things. You're not going to see questions on this, but I did just want to mention it because it is in the book and it is relevant to what we're talking about. Here, if we had income elasticities that were in between 0 and 1, so these are just going to be for normal goods when our income elasticity was positive, right? Except for inferior, that was going to be negative. When we have a positive income elasticity, if it's positive but inelastic, like in between 0 and 1, we would say these are goods that, yeah, the percent change in income is occurring, that denominator might be large, but the numerator is really small. That percentage change in the quantity demanded from this increase in income, it's not going up by that much. These are going to be things that basically you need regardless of if you have $100 in your pocket or $1,000 in your pocket, right? You're going to need 3 meals a day. You're going to need a car to, gasoline to drive to work or drive to class, wherever it is. If you have more money, you're probably not going to start buying more gasoline tomorrow. Right? Maybe a little bit, right? Maybe you don't walk quite as much, but in general, you're going to keep using the same amount of gasoline. You like that the price, or you like that you have more income and you can afford more of it, but you're probably going to keep buying about the same amount. These would be what we call necessity goods, right? Yes, they're responding to changes in income, but not very responsive. When we have things that are huge responses to income, so this would be things like, think of luxury goods, we call them luxury goods. And actually, I copy and pasted this. This doesn't make any sense. Sorry. This would have to be when it's greater than, well, no, it did. Sorry, I'm looking at this backwards. That was right, wasn't it? I looked quick and then, there we go. Sometimes I shouldn't second guess myself. So if it's greater than 1, which is what I originally had, think about what that would have to mean. Our numerator has to be relatively large, right? So it might seem kind of counterintuitive, like, well, yeah, but wouldn't I need really large percent changes in income to like afford these like higher end ticket items? Well, you are going to see large changes in income, but the relative size of the percentage change, when we think about things like a Rolex or a new house, how often, what are the quantities we typically see people purchase of a house if it was changing? Usually from 0 to 1, right? Not many people own multiple homes. And there's some people that do, but more often than not, most people are going from 0 to 1. We're always going to have a huge percent change in our quantity demanded, right? So as people have more money and they want to buy these normal goods, if they're very elastic, right, we would call these luxury goods. And that's because typically we only see the movement of quantity going from 0 to 1, which is a large percentage change, okay? So like I said, I won't throw questions out at you. So if you're already thinking you're in kind of an exam mode, don't worry too much about this discussion, okay? And this had a link just of like a study that like did the different measures of what are necessity goods and what are luxury goods. If we have a time, maybe I'll pull it up here later in class. So is your income elasticity greater than 1? This being with you is a luxury good, right? So my wife loves me finding all these memes and then using them on her. Not at all, actually. But so we have one more, which I said we're always going to have that percent change in quantity demanded in the numerator with one exception. I jumped the gun a little bit. So that exception is going to be our price elasticity of supply. But honestly, this is going to be really easy now that we know how to do the price elasticity of demand. It's going to be the exact same rules. I just take my percent change in the quantity supplied and divide it by the percentage change in price, right? So it looks the exact same. The only difference is I'm not looking at quantity demanded, I'm now looking at quantity supplied. Now here, I don't have to worry about a negative sign. Why? If I increase the price, what's going to happen to quantity supplied? Yeah, right. We have an upward sloping supply curve. They're moving in the same direction. We'll always have a positive price elasticity of supply. And then the ranges are exactly the same as for demand. If it's less than 1, we say it's inelastic. If it's greater than 1, we say it's elastic. If it's equal to 1, we say it's unit elastic. Okay? So nothing really new, right? Everything we talked about for demand just applies to kind of the elasticity of supply here. Okay. Any questions on that? So probably not spend a lot of time on that because it's pretty similar there. Right? Just like we talked about determinants of demand, we also have determinants of demand. Determinants of the elasticity of demand. We also have determinants of the elasticity of supply. So things that will influence it. So the first we'll kind of think about is the flexibility of producers. So this might seem like kind of a dumb example, but let's say I've got like a I don't know, I'm operating the Qdoba that's over here, right? And I've got one worker. If all of a sudden there's a huge change in the price of what I can sell my, burrito bowls or whatever for, yeah, I'm going to want to supply more, but I've only got one worker today, right? So today I'm not very flexible, right? Yes, there's a change in the price, but I can't be very responsive to that change. So when you don't have as much flexibility, you can't be as responsive. So the less flexibility that these companies have, the less responsive they can be, or the more inelastic they would be. As they become more flexible, so if I'm thinking about, okay, well, then I'm making hiring decisions for the next month, I hire a few more workers, now I can be a lot more responsive to price changes. Right? So, this will look different in the context of every good, but in general, what we think about is the more flexibility in your production process, right, the more elastic you can be. Right? Use the example too of so there's a couple GM plants, but there's one kind of up in like Marion, Indiana, and I don't know what they're called. They're like these massive machines that basically, I think they're like die cuts, right? So they can make car doors with them, they can make the hoods, they can make, they're a mold that's set up to produce one thing. They have a lot of flexibility to change day to day, right? Because all it is like the engineers or programmers going in on the back end saying, instead of making the doors for a Ford Escape, make doors for Ford Mustang, right? So when the price, all of a sudden, if for whatever reason, people really love these new Ford Broncos, right? And I can increase the price goes way, way up, what can they do? They have a lot of flexibility. They can take that production process, move away from producing things like minivans, right? And start producing more parts for those Ford Broncos. So more flexibility, we can be more responsive to price changes or more elastic. So what do we see companies trying to do? Well, that's why you have companies that have excess capacity, right? Because they want to be able to have the ability, if that price goes up, to ramp up their production, right? Want to be more flexible. It's really closely tied to this idea of flexibility, and it's the exact same thing as we talked about with consumers. If I have more time to respond, so like in my stupid Qdoba example, if I'm thinking I have one worker today, and all of a sudden the price of the good I'm selling goes up and I can sell way more, I try to supply more to the market today, I don't have a lot of time, I'm kind of capped out on whatever my one worker can do. But if I have more time to respond to that price change, what do I do over the following week? I hire more workers, and I'm able to increase my quantity supply by even more. So when I have more time, you can think about it, I can be more flexible. Elasticity of supply will be more elastic. Less time, I'm less flexible. My elasticity of supply is going to be a little bit less elastic or inelastic. Okay. Any questions on? Hopefully, my examples are landing with a few people. Some of them are kind of goofy, but I use them to kind of I don't know, connect with things you can kind of think about, and we don't get too lost into the weeds of one specific good. Okay. Good with that? Okay. So we'll now kind of think about how this plays out in the real world. I think these are kind of some interesting examples. So you probably answer my questions as you're reading through this. Just try to stay with me in this discussion. So in the 90s, there was this huge issue of slavery in Sudan, and these large humanitarian groups were like, okay, we've got all this money in the US, we're going to go to Sudan, and we're going to buy slaves, we're going to pay out, from the slave owners, we're going to buy them, and then set them free, right? Sounds like a great idea, right? But what happens? Sudan is not the most well-off country, especially in the 90s. So these humanitarian groups are going over, paying these large amounts of money to buy slaves and then free them. Well, if the price of slaves are going up, what do you think happens with quantity supply? it also went up, right? When these humanitarian groups came in and were paying large amounts of money for these slaves, people who had those slave owners went out and found more slaves, right? And so it actually had the exact opposite effect of what this humanitarian group did. They then wasted all this money because they freed the slaves, and guess what? Slavehold, the people who were enslaving people just went out and got them again, and increased the supply of slaves even more. So, even as something as simple as the price elasticity of supply, if this humanitarian group would have understood it, they would have tried to devise a different way to kind of free these slaves, right? So yeah, I don't know. I thought it was a somewhat interesting, kind of relevant example how we can take what we're talking about and see like it kind of play out in the real world, right? So the other one, I think it's a fun example. Well, maybe I should be careful talking about drugs and saying fun, but right, we've got this academic paper. So I will probably at some point in the semester get an announcement of. So the econ department, economics, they run these experiments, right? So they're like in a lab and they control the factors. And so this one specifically, they went out and found 120 heroin users. I'm trying to remember I might get the details a little bit off, but for the most part, I can remember this study. So these are actual heroin addicts, right? That they had in these experiments. They then gave them artificial budgets and then gave them artificial prices for different goods. So I think it was what? Heroin, cocaine, marijuana, beer. Those were the 4 things they could buy with the money that the experimenters were giving them, right? They then played around with changing the price of those goods, changing the income that people had, and see, well, what was their response? Well, think about it this way. If I give you a price for heroin, and I think here it was what? They had initially like a price of 6, and that subject decided they would buy 4 bags at that price. They then kind of increased the price to 10, and they saw, okay, now they're only going to be able to afford, or they're only going to be willing to buy 2. Well, what can we calculate if I have 2 prices and 2 quantities? Elasticity, right? Use the midpoint method. We can calculate these price elasticities of demand. So that's exactly what they did, and then kind of took an average across every single subject to see, well, what's true about the price elasticity of demand for heroin? Spoiler alert, what do you think? It's fairly inelastic, right? So, you can go through and do this. Just some interesting kind of things that were also in this study. So not only did they find, surprise, surprise, that heroin is very inelastic, they did a very similar thing, but instead of changing the price of heroin, they changed the price of cocaine. So they found that the cross price of elasticity for cocaine and heroin was actually negative. So that meant when the price of cocaine went up, the demand for heroin was going down, right? That means those 2 goods must be complements, right? So I wouldn't necessarily, I don't know, I don't know enough. I'm too square to know about the drug habits of people, but like, this is, I think, an interesting finding that we can kind of, we might have some intuition behind what we think they're complements or substitutes, but it's really hard to like, how am I going to get data on actual heroin purchases? That's not, no one's keeping a ledger, right? And so we can run these experiments and kind of artificially create these prices to actually understand what the relationship is between these different goods. So I thought this was kind of a unique, interesting example of that. Yeah, if you're interested, this paper, or this is actually gives you a good idea of kind of what economics, kind of academic papers that get published look like. I don't know if it'll pull up because we're in this room and the Wi-Fi is what it is, but if it pulls up here, we might take a look at it. So other than that, we're having time. We got 20 minutes left. So, well, no, I think there it goes. Just if anyone's kind of, so, you kind of have, you'll see, scroll down because there's some interesting tables, except for now I'm not finding them. Here we are. So like, here was like their different kind of budgets they gave people, the various combinations of prices. They then kind of run what we call regressions. So if you're in Kelly, I don't know what the equivalent is, although, I'm always a proponent. I'm always somewhat of a salesman. I think that an economics degree pairs very well. If you ever have the opportunity while you're here to double major, it pairs really well with finance, marketing. It really sets you kind of apart from everyone who's just a marketing major and a finance major. And use a lot more, like you take a class called econometrics. You understand how you can use higher level statistics to actually estimate some of these things that we're talking about. So they estimate not using the midpoint method, they actually have a much more statistically robust way of calculating these elasticities, which is what these tables are here. So if you're interested, that link's there. Other than that, let's kind of go